We use our muscles every single day to get up in the morning, to text our friends, and even just to smile. Sometimes we use our muscles without even thinking about it. When we're sitting upright, our muscle tone is what helps give us our posture. But to make all of these movements, our muscles need to contract, and looking deep inside the anatomy and the structure of the muscle allows us to understand this. A muscle is made of multiple fascicles, which contain many long strips of muscle fibers, also called muscle cells. Within every single muscle cell is a contractile unit called a sarcomere. These sarcomeres have structures within them that allow us to contract our muscles. Each sarcomere is marked with borders called Z-lines. This marks the beginning and the end of every sarcomere. There are also thick and thin filaments within the sarcomere. The thick filaments are called myosin, and the thin filaments are called actin, which also have a special troponin-tropomyosin complex attached to it, which I'll get into later. In the middle of this is the M line. Now, whenever a muscle contracts, it can only get smaller, meaning the entire sarcomere gets shorter. The Z line pushes inward, and that means the zone of overlap increases. The zone of overlap is the amount of space in which the actin and the myosin cover over each other. However, how does this contraction actually take place? In order to understand that, we need to go a little bit more deeper. Two things are happening here at the same time. For one, within your actin structure, as we can see in this model, there is a troponin-tropomyosin complex attached to it. The tropomyosin is a rope-like structure that covers the actin binding sites for the myosin, and the troponin is a binding site for calcium. So, when your muscle cell depolarizes, a large influx of calcium rushes into the muscle cell, and it connects with the troponin. This causes the tropomyosin to shift and open up the binding site on the actin. At the same time, your myosin are also working hard to get some ATP. The myosin head attaches to an ATP, and that ATP breaks down into ADP plus P, and this puts it in a high energy state, which allows it to connect with the actin binding site for the myosin. Later, that extra phosphorus breaks off, and that puts it into a low energy state. However, this low energy state allows it to change the power stroke and it pushes the actin inwards. Later, that ADP also breaks off and it goes back into the cycle of ATP, where it can allow for the muscle sarcomere to keep on contracting, allowing your muscle to actually move. That being said, this causes the sliding filament theory. Overall, the sliding filament theory is the entire action of the myosin head attaching to the actin binding site and pulling it closer, because, as I mentioned before, a contraction can only take place if it gets smaller. And it can only get smaller if the Z lines push inwards, which happens if the myosin pulls in the actin. Thank you for listening.